What's a satellite? Yep. Yeah, it's something that orbits around something else. What normally keeps a satellite in orbit around something else? Gravity. Yeah, there's a centripetal force that keeps everything in orbit around everything. Okay, if you've got an object moving in a circle, there's got to be a centripetal force in every single case. Now, that centripetal force will always be caused by something. Sometimes we're not going to necessarily know what it's caused by, but in the case of satellites, we do. It's caused by gravity. So when we're talking about satellite motion, we're going to set the centripetal force equal to the gravitational force. In physics 30, not the gravitational force. Yes, the gravitational force, that's right. In physics 30, sometimes you'll set the centripetal force equal to an electric force. Sometimes you'll set it equal to, not an electric force, a magnetic force. Okay, maybe a frictional force. Okay, but right now, mv squared over r will be equal to gm1 m2 over r squared. Now, one of the r's on each side cancels. One of the m's on each side cancels. What mass are we left with here? The mass of the satellite that's orbiting around, or the mass of the thing that causes it to orbit around, Kevin? Good, the mass of the producer, the mass of the planet if we're talking about the space station orbiting the Earth, or the mass of the sun if we're talking about the Earth orbiting the sun. It's the mass of the producer. So I'm left with v squared is equal to g times m over r squared. Sorry, over r. Plug in my numbers, solve for whatever we're looking for. Yesterday we had a problem where we were looking for not the speed of the satellite as it orbited around, but rather the orbital period, how long it took to make one complete revolution. What do we do for that? Looking for t, not v. Oh, am I going to have to pick somebody? Right? Good. We're going to say v is equal to 2 pi r over t. And then, of course, if you're looking for t, you're going to rearrange that. It becomes the circumference, as Ryan said, over the speed. Okay, so whatever you get the speed to be, calculate the speed in that equation that I gave you. Calculate the speed, then plug it into that equation that we learned on the very first day of this unit. V is equal to 2 pi r over t. Make sense? All right. We had some problems to work on. The last set of problems you worked on were on page 279. Were there any issues with those questions on 279? Yeah. Number 2, okay. Is number 1 okay, guys? All right, let's take a look at number 2 then. It says the Chandra X-ray satellite takes X-ray pictures of high-energy objects in the universe. It orbits the Earth at an altitude of 114,593 kilometers. That's a long way up. We're talking about the space station orbiting at an altitude of 400 kilometers. That's 400 kilometers above the surface of the Earth. This is 114,000 kilometers more than the space station. We know what to do here, guys, right? FC is equal to FG. We're going to say mv squared over r equals gm1 m2 over r squared. Why do I derive this equation every time? Whenever I'm doing a problem like this, I go right back to the beginning here and derive the equation. How come? Because it doesn't appear on our data sheet. This equation that I have written down right now at the bottom doesn't appear on our data sheet. You can either remember it or you can figure it out. Okay? If you're anything like me, you're not very good at remembering things. I'm 42 years old. I'm an old man now. I forget things all the time. Yeah, I sent an email this morning talking about how I forgot to send this email earlier. Well, I had to include an attachment. I almost forgot to include the attachment on the email that explained how I forgot to send the email in the first place. Yeah, I can't remember equations like this. Figure it out. Okay, then you don't have to worry about forgetting things. Okay, logically, FC is equal to FG. Figure out this equation right there. Okay, what do we want to get here? Period. Well, we don't have it in this equation, so let's get speed instead. Gm over r. G is 6.67 times 10 to the minus 11. The mass is the mass of the producer, which would be the mass of the Earth in this case, 5.97 times 10 to the 24. Divide that by r. R is going to be, what's r going to be? 114,593 Kilometers. Should we tack 3 more zeros onto there? Because we don't want kilometers, right? We want meters. Make sense? Is that good? Let's square root that. What do we get for speed when we square root that? Okay, figure it out. Everybody figure it out. I'm going to ask somebody in 1 minute. Garrett, what's the speed? 1.9 times 10 to the 3, thank you. Can we give me a couple more decimal places, actually? Unless it's exactly 1.9. Okay, does anybody else have a couple more decimal places? Tom? 1,864.10. Okay, thank you. Now, the reason I don't want to round that to 2 digits, Austin, Garrett, you had the right number, right? But it's not a final answer, so we don't want to round it to a couple digits until it's a final answer, right? Keep it to 4 or 5 digits there. All right, so that's my speed, 1,864.10 meters per second. Question, Kathleen? How come we wouldn't add the radius to the altitude? Let me read that again. Oh, wait a second. It's orbiting the Earth at an altitude of 114,593. Okay, that actually looks like it's above the surface of the Earth, right? So what does that mean, Kathleen? Yeah, if we're talking about above the surface, we have to add in the radius of the Earth. Does that make sense? Anybody else catch that? Yes? And say something. Okay, don't wait for Kathleen to point out my deficiencies. Thank you, Kathleen. We're going to add to this 6.38 times 10 to the 6. That's the radius of the Earth. Now, that's a little bit ugly looking, okay, but it's essentially the same as the calculations you just did. Just make sure you use some brackets on the bottom there. Okay, what do we get for speed now that Kathleen's corrected my mistake? 1,815.88 meters per second. Agree with that, guys? No? Oh, boy. Sorry, Cade. You get voted off the island, I guess. Is that it? 1,000 what? 1,814 point. We'll go 286. 3 digits is good. 3 decimal places is good. Anybody agree with that one? Okay, Janessa gets to stay. 1,814 meters per second. Okay, it's pretty quick. Pretty quick. Now let's find the orbital period by saying v is equal to 2 pi r over t, and t is equal to 2 pi r over v. All right? 2 times pi times r. R is going to be 114,593,000 plus 6.38 times 10 to the 6. Divided by the speed, 1,814.286. And when we do this, we should get a period of, I think, 4.19 times 10 to the 5 seconds. Is that right? Okay, it's a bit of a tricky question, right? Bit of a tricky question here. Okay, first of all, I mean, FC is equal to FG. That's the easy part of it, right? The first thing that we had to recognize was what I didn't recognize. I just read it too quick and didn't spot that. The fact that we needed to add the radius of the Earth. If you're given the distance above the surface, you need to add the radius. If you're given the distance from the center to wherever, then you don't need to add the radius of the Earth. If you get a test question and it's not clear to you what you're given, put up your hand. Okay? I'm not going to tell you whether you have to add something to it or not, but I will tell you if the number that's given to you already includes it. Does that make sense? If you're unsure about that, if you're just not sure of the wording of the question. And then the second thing we had to do, of course, is the whole v is equal to 2 pi r over t to solve for t. All right? I'm going to do one more example. This is the last example that we're going to do this unit. Okay, there's no practice problems to go along with it. Just one example to finish things off. Talks about a geosynchronous satellite. A geosynchronous. What does geo mean? The geocentric model of the universe was the Earth-centered model of the universe. Geo means Earth. Synchronous means synchronized. A satellite that's synchronized with Earth. It maintains the same position above the Earth at all times. What's the use of that? Why would we want to have satellites, some of them at least, that maintain the same position above the Earth all the time? When we look up in Calgary and spot a satellite, it's always in the same place relative to us, if it's geosynchronous. Why? Who's got satellite? Go ahead. Perfect. Kevin says so you can watch TV. Who's got satellite TV? I've asked this question before, I know, but a few of you have satellite TV. Your satellite receiver is pointed at a certain place in the sky. It's pointed to a satellite in the sky. If that satellite is constantly moving relative to the Earth, then your satellite receiver will also have to constantly move depending upon where that satellite is. It has to be pointing at the satellite all the time. It has to be a geosynchronous satellite. Okay, other satellites, GPS satellites, all satellites. There's certain satellites that we need to know where to find them all the time. We don't want to guess where they are. Okay, we need to know where they are at all times. We want to know the height above the surface of the Earth that a geosynchronous satellite must be placed. All geosynchronous satellites, by the way, are placed at the same height, the same orbital altitude, all of them. Whether it's your Bell Express View TV or whether it's whatever geosynchronous satellite, they're all at the same height. What is that height? Well, let's start off by saying FC is equal to FG. It's a satellite that's held in orbit by gravity. R's cancel. One of the M's cancel. We're left with V squared is equal to G times M1. G times M, we'll just say, over R. So far, so good? We want to find R, right? We want to find R. Okay, so let's plug in the value of G. We have it. Let's plug in the value of M. What mass do we use? Is mass of the satellite or the mass of the Earth? Time to pick somebody. Jazzy? Mass of the Earth, good. Speed, we plug in. Oh, wait, we don't know what the speed is. How fast is the satellite moving? So we don't know what R is, and we don't know what V is. Oh, wait, we can find V, right? We can find V by saying it's 2 pi R over T, right? But we don't know what R is. Oh, boy. Jazzy, what are you suggesting I do? Okay. Oh, the satellite travels that? Because the V would be the speed of the satellite, not the speed of the Earth, right? Yes? No, that's a good idea, but no, because the Earth is moving at a certain speed around the sun. We're talking about something that's orbiting around the Earth. So regardless of how fast the Earth is moving, the satellite would be completely independent of that. Let's do this. Let's say 2 pi R over T squared equals GM over R. You see what I've done there? I don't know what R is. I couldn't find the value of V, but I do know the expression for V. It's 2 pi R over T. So let's plug in not the number for speed, but the expression for speed. Now, let's pull the squared inside the brackets here, distribute it here. So 2 squared is 4 times pi squared times R squared over T squared. Is that okay? We want to find R. So let's get all the R's together. Let's take this R up to the top by multiplying. It becomes 4 pi squared times R, oh my goodness, R cubed over T squared. Let's get R, I was going to say let's get R by itself. Let's get R cubed by itself right now. Okay, the T squared goes up by multiplying. The 4 pi squared goes down by dividing. Oh boy, let's hope we don't get a question like this on the test. How do you find R? The cube root. Okay, now it looks easy, right? We've got the mass of the Earth. pi is 3.14. We got g. Oh, no. What's t? Do we know what t is? Yes, we do, if we read between the lines. If it maintains the same position above the Earth at all times. Sorry? No, because it's moving. Okay, Calgary, Alberta is here right now. Okay. When will Calgary, Alberta be in the exact same position relative to space as it is right now? In 24 hours, in a day. Okay, if the satellite is above us at a certain height and it maintains the same position above Calgary, how long is it going to be before it's in the same position? 24 hours. So the orbital period is going to be 24 hours, which corresponds to how many seconds? 24 times 60 gives me minutes, times 60 again gives me seconds. I think it's 86,400, I think. Is it? Okay, now we can do this. We're going to say it's the cube root of 6.67 times 10 to the minus 11 times the mass of the Earth, 5.97 times 10 to the 24. Remember, it's the Earth, not the satellite, times t squared, 86,400 squared, divided by 4 pi squared. Wow, that's ugly. Let's get a number inside that cube root sign for a second. First, let's do that first here. Let's say 6.67 times 10 to the minus 11 times 5.97 times 10 to the 24 times 86,400 squared. Okay, we get a number on the top there. Let's divide that by 4 pi squared. Use some brackets here. 4 times pi squared. End those brackets. Okay, that's what's inside the cube root sign now. How do you do cube root? Sorry? Math 4. Where's the math function on there? Right there. Okay, let's go math 4 or math 5 you could use as well. Okay, math 4, which is cube root. The answer, and lo and behold, we get 42226910. Is that my final answer? Oh my goodness, it's not. What have I just found? That's what I've just found. What did I want to find? This. So what do I got to do? What do I got to do? Add the radius of the Earth in? Jazzy? Subtract the radius of the Earth. I get 3.58 times 10 to the 7. That makes sense. That's a hard question, hey? Wow, that's a hard question. The good news is I won't give you a question that's that hard on the test. I won't. Okay? I don't think that would be fair to give you that on the test. So why do I give it to you right now? Well, look, if you can follow that, if you can understand what we've done there, then the other questions are easier. Right? That's the goal there, right? Is to make the other questions that you're going to see on the test a little bit easier. All right? Let's give you a quick little outline for the testers. Any questions on that before we give you the outline? No? All right, let's give you the quick little outline, and then we'll wrap it up here. What do we do first? Well, we defined uniform circular motion. Uniform circular motion. We define frequency. We define period. And then, of course, the speed was 2 pi r over t. We just referenced that just a second ago, right? V is equal to 2 pi r over t. We talked about centripetal. Centripetal meaning center seeking, centripetal acceleration, centripetal force. We need to know what those are. The fact that they point toward the center of the circle. We need to know the mathematics of them. A is equal to v squared over r. F is equal to m times v squared over r. How can you have an acceleration when something's going at a constant speed? Not because the direction's changing. An acceleration isn't changing speed over time, it's changing velocity over time. If I cut the string, when I swing my keys around my head and I cut the string, which way are they going to go? Now that there's no longer a centripetal force. Where are they going to go? They're going to go off in a straight line. What takes it off in a straight line? It's the I word. Inertia. Yeah, inertia takes it off in a straight line. We also talked about centrifugal force. Why did I put that in quotation marks? Because it's different than centripetal. It is different than centripetal. Yep. It's imaginary. Centripetal force is center seeking. Centrifugal force is center fleeing. The force that pushes it out toward the outside of the circle is an imaginary force. You guys saw in the Cirque du Soleil video that I showed you the other day, right? You guys saw the guy was jumping. Where was he going? Well, he ended up going to the outside of the circle, right? But you could see clearly what his path was. As he was going to the outside of the circle, he was going in a straight line. And then what happened? Well, he reached the outside of the circle. Okay? He made it to the outside of the circle, but he wasn't pushed out to the outside of the circle. He was going in a straight line, and the outside of the circle just caught up with him. So what is really centrifugal force? Well, it's the centripetal force pushing you in. Okay, that's what you feel as centrifugal force, but largely it's what? It's inertia, again, taking you in a straight line. So centripetal acceleration is a force and acceleration that points toward the center, which is real. Centrifugal is that pseudo force that pushes you to the outside, but it doesn't really exist. Then we did vertical circular motion. Within vertical circular motion, we analyze the top of the circle and the bottom. We don't need to worry about in between, just the top and the bottom. Be prepared to find things like the normal force, the apparent weight. By the way, apparent weight is the same as normal force, right? If I ask you to find apparent weight on Monday's test, how heavy does the person feel? What am I really asking you for? The normal force. Also be prepared to find minimum speed. When I ask you to find minimum speed, I want you to analyze the top of the circle. Draw a free body diagram for the top of the circle. And then when you're solving for that minimum speed, make sure you set Fn equal to 0 in that case. The normal force is 0. When I swing my keys around my head, you guys saw it again on the Cirque du Soleil video the other day. Okay, the guy was going around in the circle, the vertical circle in the Wheel of Death. What happened when he was going just a little bit too slow to not stick on that circle? He fell out of the circle, right? If he was going fast enough, he went all the way around. If he was going a little bit too slow, then he fell out of the circle. Okay? At the point where you're going just barely fast enough, that circle that he was laying on didn't have to push him in at all. Okay, below that speed, well, all bets are off because he's not going in a circle anymore. Above that speed, gravity wasn't strong enough to supply the centripetal force on its own. Okay, that piece of metal that he was laying on had to help. So set Fn equal to 0, and then you're just going to solve for V there. Then we started talking about heavenly motion. Okay, we had Aristotle, etc. All those guys that heliocentric model, Copernicus, the geocentric model of the universe. Don't need to know a whole lot about that other than basically what they said in the order in which they said it. I'm going to specifically mention, though, Kepler here, because Kepler had 3 laws. The law of elliptical orbits, the law of periods, and what was the other one? The law of equal areas, yes. The law of elliptical orbits, the law of equal areas, and the law of periods. No calculations with this, just know the 3 laws and what they were, basically, what they said. Well, we went from heavenly motion to gravity. Not gravity in the sense of, F is equal to m times g, but specifically Newton's law of universal gravitation. Everything exerts a force of gravity on each other, not just the Earth, but everything does. F is equal to gm1 m2 over r squared. Included with that was the Cavendish torsion balance experiment. Remember, we had that thing hanging, put the mass nearby the other mass. We observed how much it twisted. We were able to calculate g from that. And we talked about gravitational fields. Okay, what is a field? The producer, the experiencer, the equations. Don't get the 2 equations mixed up. There's a mass in both. Make sure you use the right mass. I'm telling you right now, there is a question on your test where you're asked to find a field strength. You are given 2 masses, the mass of the producer and the mass of the experiencer. What do you think typically probably a third of my classes do? I give you 2 masses. What's the temptation when I give you 2 masses? No. Go ahead. No. Gm1 m2 over r squared. Is that gravitational field? That's gravitational force. Okay, if I ask you for field, I don't care if I give you 2 masses. Don't do that. If I ask you for field, use either the mass of the producer with the producer equation or the mass of the experiencer with the experiencer equation. Got it? Don't find the force if you're asked to find field. Now, some of you are still going to make that mistake on the test on Monday. Okay? Please don't be that person. Finally, the last thing we did, satellite motion. And of course, with satellite motion, we've been doing that the last couple of days. FC equals FG. And then do your thing from that. Any questions on any of those things? Nope. All right. That's it then.